Hello everyone, in this video we are going to learn how to use the CATT3 software for finding the parameters of the refrigerant at different points in the refrigeration cycle. So here we have a set of the recorded data from the air conditioning test rig and mainly for the refrigerant side. And as you can see here that I have the condenser inlet temperature and pressure. I have the condenser outlet temperature and pressure and the evaporator inlet and mainly the outlet pressure and the temperature. This is the CATT software. Again, to put these things on parallel, I found the parameters for the points 1 to 5. And to remember what are the points 1 to 5, then number 1 is going to be the inlet of the compressor unit. Number 2 is going to be the outlet from the compressor and inlet to the condenser. Number 3 is going to be the outlet from the condenser unit to the expansion valve. Number 4 is going to be from the expansion valve to the evaporator unit. And number 5 is going to be the exit from the uh, evaporator unit. Now, we are going to find the followings. We said that we know the pressure and the temperature. We are going to use that to find the enthalpy, specific volume, the saturation temperature, and the X value in the case of having the mixture of the liquid and the vapor. And that's mainly what we're going to have after the expansion valve at the point number 4. Now, by default, the CATT3 actually have the refrigerant set at the R134A. You can change the type of the refrigerant, including the CO2, the R11, up to the RC318. Also, I have other options like finding the properties of the water, finding the cryogenics like the ammonia and the argon, the ethane, neon, and the oxygen. For the air, for the ideal gases, for the compressibility, and for psychrometric chart. For the psychrometric chart, my advice is still using you have to keep using the Sugar Engineer's website, because I think that their calculator is the most convenient one we have on the web. Now, the other option I can apply here is going to be about adding the calculate process, which is the same this one we have here. Change the unit. We're using SI unit. I can change it to the IP. What are the general properties we can have? The saturation properties, I can choose between these two values. I can use the TS diagram to be sketched here. I can use the BV diagram, and I can plot the process itself. Now, if I'm going to plot the process, I should start here once again from having the 1, 2, and 3, 4, 5, and thus is going to be plot the pH diagram directly. Now, I'm going to start with my first calculation, which is going to be done by pressing that. I can choose what are the different parameters, the main two different parameters I'm going to have, and to calculate the others. Now we have the temperature and pressure. Later we're going to use the pressure and the enthalpy at the point number 4. And I'm going to start with this one first. Now at the point number 1, we said that's going to be the compressor inlet. At the compressor inlet is going to be the evaporator outlet. So we have the temperature is going to be 12.35 centigrade, and the pressure is 193.1 kilopascal. Now the units here is megapascal, so I have to divide this value by 1000, and thus I'm going to end up with 0.139. By saying OK, I'm going to get the parameters listed. Now the only thing we don't have is going to be the saturation temperature. Now, simply because the saturation temperature is going to be calculated at the point where we're going to have the outlet from the expansion valve, the inlet of the evaporator. So now we are going to take the main values, which is going to be the specific volume, put it on table, the specific enthalpy, say it here, 411.9 kilojoule Kelvin, kilojoule per kilogram Kelvin, and this is it. I don't have to use the specific entropy or the internal energy. Now again, to calculate the second point. The second point, as we mentioned earlier, is going to be the condenser inlet, where we're going to have, or the compressor outlet, the same point. So in this case, this will be the condenser inlet and the compressor outlet. Temperature is going to be 74.72. 74.72. Now the pressure is going to be 1098.7. So this will be 1.09 if we change it to megapascal. 1.098. And let's say we're going to put the 7 after that. 7, 2. I'll do my calculations here. Now this will be the temperature 74. The megapascal is written back once again. Specific volume is going to be 0.022. Okay, I approximate that. And the enthalpy is going to be 455.4. 400. Well, actually, I have some slight difference. Okay, and this is it. And this situation is going to be a superheated vapor after leaving the compressor unit. Now, the other point we're going to have is going to be the point number 3. Now, point number 3 is going to be the condenser outlet. Now, for the condenser outlet, I do have the pressure and the temperature again, so I can find the enthalpy from there. That's the condenser outlet. So I will do my third calculation, and I will put the temperature, which is going to be 40 degree, 0.05. And the pressure here is 1029 kilopascal, so this will be 1.2885. Okay, and now I got the value of the enthalpy to be 256.5. Okay, this is the enthalpy, this is the specific volume. Now my saturation temperature is going to be the same, of 40.05. Okay, now the same thing is going to be transferred. Well, just let me check that. Yes. Okay. Now the same saturation temperature is going to be at the inlet of the condenser unit. Well, actually, this should be 40. I have, as I told you, because I have to change this one manually. Maybe this came from the previous calculation I've done earlier. Now the point number 4. In the point number 4, after the expansion valve, we said that the main thing we are going to have is that the enthalpy at the point 4 is going to be the same as the enthalpy at the point 3. So from here, I'm going to do my next calculation. I'm going to choose now the temperature. No, temperature is going to be different. I'm going to use the number 4. The enthalpy is going to be the same, and the pressure is going to be at the evaporator inlet. I'm going to use the same pressure we have here. So thus I'm going to apply that temperature. I don't use it. I'm going to use the temperature and the enthalpy, pressure and the enthalpy. Now you can see that the parameters has been changed. Now the specific enthalpy I'm going to use actually has been transferred directly to 256, and the pressure is what I'm going to need to change, which is equal to 0.193. 0.193. Now I will click that. Now you can see that it's gave me the value for the quality of the refrigerant, because this one is going to be considered as a liquid vapor mixture. So this will be my X value. I'm going to put it here, and I'm going to do the other calculations where the temperature is minus 10.96, and this will be the saturation temperature. This saturation temperature is going to be all the way through the evaporator unit and the compressor inlet. Now I got all these parameters, including the enthalpy is going to be the same, and the specific volume is going to be 0.036. Okay, and we finish with this line. Now the line number 5 is going to be actually the same parameters we are going to use by using this temperature and pressure. So I will do another calculation. Calculate. Okay, this will be the evaporator outlet. So I will go back to the temperature and the pressure, and the temperature we're going to have there is going to be 12.35. That's the refrigerant after absorbing the heat from the air in the air circuit. So this will be 13.355, and for the pressure it's going to be equal to the same 1.193. So click OK. So the last table row is going to be the calculation and the evaporator outlet. So this will be the specific volume, and well, I have a small difference as once again. I should update that. And also I have the specific enthalpy of 400.9. Okay, and of course the saturation temperature is going to remain the same, and this will be a superheated vapor. So we're not going to have any quality for it. Now I got these parameters, then I can start to do the calculations. I hope that this short video is going to be good enough to make you understand how to use the CATT software. If you have any question, you can simply send me an email. Thank you very much.